Hey class, today we are going to be going over structures and enumerators. Some of the things that I want to go over in this lecture is concatenating different data types through the use of something called string stream. And then also, of course, going through what a structure is, how it relates to object-oriented programming, and then also enumeration. So a structure is really cool, but it's a little abstract to get your head around at first. Basically, it is a variable that has different parts to it. So if you look at this little screenshot here, um, you first declare struct. That's how you're telling the program that you're defining a structure. So that will always be the same. And then you name it. You name the variable, for lack of a better term. Um, what is the thing that you're defining that's going to have all the parts in it? Then, just like a function, you would put curly braces, the starting and the ending curly braces, and then within it is where you would put different variables or different parts to the structure. So in this example, you have structure named part, and in it you have three variables. You have a model number, which is an integer, a part number, which is an integer, and then cost, which is a float. And these are all the members of the structure. And then, yeah, these braces is what delimits the structure members. And then, like always, you always use semicolons to end, and you want to use a semicolon at the end of the structure as well. So an example would be like a car. I like using examples with structures that kind of make sense in our real world brains. So a car, there's lots of different parts of a car, right? For example, the car that I own is a 2014 Chevy Cruze. So if I wanted to create a structure that where an end user could define all the parts to their car, so the make, the model, the year, all these things, you could make a struct, and like I said, you just type in struct here, and then you name it. What is it going to be named? It's going to be a car. Within the curly braces is where I'm going to put the different parts to it. So I want to know the year of the car, and I want to know the model of the car. Um, so then in my main here, car is my data type, right? It's of type car, just like we have type integers, type strings, type booleans. This is of type car. It's my own custom data type that I just defined. So, type car, what is the name? I'm naming it Chevy because that's what I own, right? So that is my structure, my Chevy. Within the Chevy, I have different parts to it. I have the year and I have the model. So to define these things, I would type in my car struct, which is Chevy, and then I put this dot operator here. I just put, a little period, and then I would put in the variable that I want to reference. So remember, within my struct, I have both year and model. So here, I want to put Chevy, referencing my struct, dot year, and it's 2014. Then I want to put Chevy, once again referencing my struct, dot model, and I'm going to put in Cruze. So now my Chevy struct has these two elements defined. It has the year and the model defined. And if I wanted to make another one, I could. I could do car Ford, right? And then if I wanted to do, it's going to get kind of hard to see, but I could do Ford dot year, and I could do Ford dot model. And I can do this as much as I would like. I can keep defining these different structs and then defining each member of the struct. So string streams, little bit of a tangent outside of structs. String streams are a way that you can kind of concatenate a bunch of different things into a single string variable. So with a string stream, it's important to make sure you put this as your pre-processing directive. You want to include stream. And let's say I wanted to make a function. If we're still kind of going off this example here, I want to make a function called print car. It's the return type is string, and then I'm passing one parameter. The parameter is going to be of type car. Remember, car is the name of the struct that I defined, and my name of my variable I put Chevy. So within this function, I have to declare my string stream. So I would type in this, and then it's like a variable name, whatever you want to name it. I usually go with like SS. Some people like to put S-stream. I don't know. It doesn't matter. Put whatever you want. Put Bob. Then once again, I'm going to define the year of my car, the model of my car. So Chevy.year, Chevy.model. And then this part's interesting. Instead of doing like a cout like you would in a void function, I want to actually return a string. So what I can do is I can put put the year, Chevy, put the model. So this would say I own a 2014 Chevy Cruze. Now, I couldn't just return this whole thing as a string because year here, that isn't a string, nor is model. But what I can do is, since I'm using string stream, instead of typing cout here, I've just put SS. And then I would still put those extraction operators like normal, just like it was a cout. That saves this whole entire thing kind of in the string stream variable. And then what I'm returning is SS, and then you have to put .str. That's to kind of convert it to a string. And then that's what's being returned. So now I have a string being returned from this function, and the whole thing is going to be a string now, and it's going to say I own a 2014 Chevy Cruze. So string streams are really important and will probably be useful for your homework assignment this week. Okay, switching gears to enumerators now. Enumerators are a lot more simple, and really their purpose is for organizational purposes for a developer. If you work at a company as a software engineer, you write some code, then a developer after you has to come and add to your code, modify it, patch it, whatever. This is an organizational tool that will help them understand your code and hopefully avoid some errors. So what you do is you're assigning a number to a named value. So the way that you would define an enumerator is actually really similar to how you would define a struct. As far as you type in enum, you always will type that in, and then the name of it. So in this particular one, I want to go through some of the months of the year. So I do my curly braces, and then I just type in the names here, and you can just have them comma separated just like this. You don't need to put values in there. You just type this. Basically what it's doing is it's assigning counting numbers, and by default it'll start at 0. So down here I just want to visualize what it's doing. Jan is assigned the value of 0. Feb is 1, March is 2, April is 3. So this would be 0, 1, 2, 3. So later in my code, if I ever wanted to, let's say I'm having the end user type in the month of year and they put in a 3, then later I can just reference, it's just a label. I can just say, April here represents 3. You don't have to start at 0 though. Starting at 0 is just by default. So if I assign one equal to 4, that means we're starting at 4 here, which means this would be 5, 6, 7, as you can see here. I could even go real crazy. I could do this, and then I could do that. So now this would be 0, 1, 12, 13, right? This is only for counting numbers. You can't do decimal values. It's only integers. Okay, the last thing I want to do is just kind of go over a practical use of an enumerator. So right here, I define my enumerator. I assign January to 1, so it's 1, 2, 3. And then, down here in a function, I defined an integer variable named month, and I'm doing a cin here, so the end user is going to type in the month. And then a switch statement. So depending on what number the end user typed in, is what it would print. So notice here, instead of putting like case 1, case 2, case 3, I can put these labels. Case if it's January, if it's February, if it's March. Like I said, this isn't something that the end user would ever see. This is something that a programmer could visually see and understand and hopefully get through their code a lot quicker. So if I typed in a 3 here, if I typed in a 3, then it would say case March, because it's March is equal to 3, right? 1, 2, 3. And then what does it do? It's just going to print March to the console. So that's pretty much it, honestly, for this week, for this lecture. It's not a lot of material this week, but we are one step away of actually learning object-oriented programming, especially with structures. Structures are a very, very simplified form of object-oriented programming, where you have the structure, this object, and within the object you have different members. You have different parts to it that can have their own values. Object-oriented programming is just one step further. You're going to have these members, but you're also going to have functions that can do things. So really take the time to understand structures, and if you can understand it and code it, you guys are going to be totally ready for object-oriented programming next week. Good luck, and please, as always, reach out if you have any questions or need help. Thanks.